Hello everyone, welcome back. This is 14th of June and likely the monsoon will reach Odisha today. So what is this monsoon? Okay, what is this monsoon? What are the factors affecting monsoon? What are the types of monsoon? What actually regulates the monsoon? We will discuss in this particular lecture in brief or in detail, if you can say, different concepts of monsoons and how monsoon abnormality happens and what are the factors affecting monsoon in India. So basically today we are going to discuss about Indian monsoon. Okay, today we are going to discuss about Indian monsoon. So what is monsoon? Monsoon is basically, it was derived from an Arabic word that means global wind circulation or reversal in global wind circulation. We have regarding global wind circulation and pressure belt of world, we have already a separate lecture, and you can follow that and you can go and watch that for the concepts of pressure distribution and global wind circulation. So basically that global wind circulation, when there is a prominent global wind circulation or reversal of global wind circulation, that is called monsoon in Arabic term. Okay, so how this monsoon happen? Generally it follows the land and sea breeze. If we'll say a local wind pattern, then land and sea breeze is one important characteristics of wind circulation. Like if we'll go to coastal area, so what happens in coastal area, suppose this is the ocean and this is the land mass. So basically when solar radiation fall on both these land mass and the water body or ocean, then what happens? Land mass will easily warm up because the specific heat, if we will talk about specific heat of land is 0.2 to 0.5, whereas specific heat of water, that is 1.0. So specific heat means calorie of energy that is needed to increase 1 gram substance to 1 degree Celsius. Suppose we are taking 1 gram substance. If we want to increase the 1 gram substance to 1 degree Celsius, how much calorie of energy is required? Here the calorie of energy means solar radiation. So how much solar radiation will be required to increase 1 gram soil or earth and 1 gram water or 1 ml water? So in case of soil or land, it is 0.2 to 0.5 calorie, whereas in water it is 5 times higher. So if solar radiation is falling, same equal amount of solar radiation is falling on Earth's surface and the water bodies or ocean, then it will take more time to warm up the ocean, okay, than the land mass. So what happens when it quickly the land mass the temperature increases, then what happens? The air surround or the air that is just nearer to the ground level, that will warm up, and when air mass warm up, that becomes lighter and it will move upward. This air mass will move upward. So what will happen? The air mass which is above the ocean, that will move towards the land mass, okay, and along with the movement of air mass, it will have some water molecule with it. So it there is normalized temperature during summer, or you can say during daytime, as the air mass that is moving from water bodies or ocean towards the land mass along with some moisture, okay. So and a reverse pattern happens during night time. During night time, what happens? The land mass will quickly release that temperature. So there is a law, the body which quickly absorb the temperature, it will also get which gets hotter at the faster rate, that also that object will be cooler at the faster rate. So land mass will release that temperature at a faster rate than the ocean. So in night, what happens? The land mass will get cooled easily, whereas the it will take time to cool down the ocean. So what happens? The reversal wind direction will happen, that will move from the land mass towards the ocean. So it is called sea breeze and land breeze. From which direction the wind is coming, according to that it is named. So in daytime you can find sea breeze, in night time you can find land breeze. So this is how, this is a local phenomena. But in global phenomena, if you will see, warming up of oceans and the complete land mass, like if I'll say how Indian monsoon happen. suppose this is our globe. We have already discussed about the pressure distribution and pressure gradient. Suppose this is the equator, this is 30° north latitude, 30° north, and this is 30° south, and this is 60° north, and this is pole, and this is 60° south. Okay. So basically India falls near this. Okay. India falls at this place. Okay. So basically India falls at this place. Okay, 8° to 32° north latitude. Okay. So it is nearly equator and the tropical and subtropical type of climate you can find in India. So if I'll take into larger size, let's say this is our India. My graphs are very poor, so I cannot draw one like proper map of India. So I am just excuse me for that. Okay, so let's say this is India. Assume, okay, and this is the equator line. For example, this is the equatorial line, and this is, let's say, the 30° north, and this is 30° south. Okay, I'll just describe how this the global wind circulation happen. Okay, for example, this is the equator. So this is our India, and this is the equatorial line, and this is the 30° south equator, and this is the 30° north equator, for example. Okay, so what happens during summer season? As this the sun moves northward, so all the continent like China, India, they will warm up at faster rate. They will warm up at faster rate. So higher temperature you can feel in summer, or before monsoon there is higher temperature over India. Yes or no? May and June, higher temperature. So what will happen? There is low pressure will develop in India. There will be low pressure belt in India. And whereas south of equator in this region there will be high pressure, because there is movement of solar radiation or sun towards north of equator. So there is high temperature in north but low temperature in south, and as the temperature is low in south, the pressure will be higher comparative to the northern India. The northern India pressure will be lower, atmospheric pressure or atmospheric air pressure. Okay, so what will happen? Always wind moves from high pressure belt to low pressure belt, as we know. So wind will blow from southern part of the globe to the northern part. So how this wind will blow? As we know, the southern part of, or the subtropical wind, that is from 30° south to equator, it is moving like this, southeast. Okay, southeastward. This is the equator, and this is the 30° south. So it will move like this. Okay, next what will happen? See, this due to Coriolis force, this is moving like this, southeast. Otherwise it will move like perpendicular, okay, to the equator. But due to Coriolis force, this we have already discussed in pressure gradient. This moves like southeast. Suppose this is called southeast trade wind. Okay, so due to global circulation, okay, or earth circulation, that is called Coriolis force, it is moving like this. This is called southeast trade wind. Okay, but due to local factor, as here there is low temperature in India, over India it is low temperature, low pressure, sorry, low temperature and high pressure. Again, low pressure zone in the low pressure air at the continental part, like India, above India. So what will happen? Wind from equator, that will move towards the 30° northern latitude. Okay, this is 30° northern latitude. So this wind, again, it will deflect. The normal pattern is like this, but as there is low temperature, low pressure over India, this wind will, as this is the high pressure wind, so it will move like this. After crossing the equator, it will move like this, because there is low pressure over India. Okay, so this wind will move like this. Okay, so what will happen? This is called, the name was previously southeast trade wind. Okay, but due to local phenomena, again India, above India there is low pressure and this is high pressure wind. so it will deflect like this. Okay, so it is called, this deflection or this wind are called southwest monsoon wind, southwest monsoon wind. Okay, so this has two branch, southwest monsoon wind has two branch, one is Arabian branch, another one is Bay of Bengal branch. Okay, this is called Arabian branch. Okay, because this is moving over the Arabian Sea. Okay, then this is called Bay of Bengal branch because it is moving over Bay of Bengal Ocean. Okay, so this Arabian branch, then fine, this Arabian branch will enter or will touch Kerala. This is Kerala state, so it will touch Kerala at 1st of June. Generally that is the over a long period, that is called onset of monsoon period, first week of June or 1st of June or may last. Few days vary, like 7 days varies or standard deviation, so it may be the last week of May or it may be first week of June. It will touch Kerala, then subsequently it will move eastward and northward. Okay, so what happens here, there is here at this point there is Western Ghat. Okay, Western Ghat or Karnataka and Maharashtra, Western Ghat is there. So what happens when this wind, that is southwest monsoon wind, that carries huge amount of moisture while crossing the Indian Ocean and the Arabian Sea, so that will precipitate more towards the windward side of the Western Ghat. Windward side means, let's say this is let's say this is the hill. Suppose from this side wind is coming, this is called windward side and this is called leeward side. So there will be always higher precipitation at windward side, and after the precipitation happen, then it will cross, this wind will rise above and it will cross the hill and it will move again. So there will be low precipitation because already the precipitation has happened, already the moisture that is being carried by the wind, that is already precipitated in the windward side. So there is higher precipitation in windward side and low precipitation in leeward side, as this is a descending air. So here this is the Western Ghat, so there will be high precipitation towards the west of Western Ghat, and towards the east you can find low precipitation. So that's why some interior part of Maharashtra, that is being drought prone area, there is very low precipitation happens, whereas in Mumbai you can find during monsoon it is very difficult to travel because of high precipitation. Okay, that is because that is western part of the Western Ghat. Okay, next this wind moves like northward and towards the east. Okay, but it will not touch at this point, like Tamil Nadu, eastern coast of Tamil Nadu and total state of Tamil Nadu and eastern part of Andhra Pradesh. It cannot touch there. This is not Andhra Pradesh, now it is Telangana. So eastern part of Telangana and the state Tamil Nadu, it will not, this wind moves like this and this wind moves like this, so it will not touch there. So Telangana and eastern part of Telangana and Tamil Nadu, they are not receiving rainfall by the southwest monsoon. Okay, they will take there will be the precipitation when northeast monsoon will come, so I will talk later on. Okay, now it will move gradually towards the north, but gradually that particular wind, that is the southwest monsoon wind, the moisture as it is precipitating in the way on the path, so the precipitation will be less towards the north and eastern part. Okay, and now this is the Bay of Bengal, Bay of Bengal branch of the southwest monsoon. So that will reach to northeastern state. Okay, and it will be diverted from this is the eastern Himalayan zone, so it will be diverted towards the west. Okay, and towards west it is precipitating highest at this Meghalaya and Assam. Okay, it will be precipitated highest. So the wettest part of the earth, you know, that is Cherrapunji of Meghalaya, it is like 10,000 millimeter of rainfall that is precipitated by the southwest monsoon. And after this striken by Himalayan range, obstruction by Himalayan range, it will move towards west, and this Arabian branch and Bay of Bengal branch, they will clash at Delhi somewhere around last of September or mid of October, they will clash there. Okay, so this is how, this is the driest part of the India, that is Rajasthan. Okay, so up to Rajasthan, when the Arabian Sea, Arabian branch or the southwest monsoon that coming above the Arabian branch, the precipitation has already done in the path, so there is very less precipitation or moisture in the southwest monsoon wind while it is reaching Rajasthan. Again, the Bay of Bengal branch, it is also laden or precipitated in northeast India. So when moving westward, it is very precipitating, lesser rainfall, okay, towards the west. So while they crash in Delhi, or there is very less precipitation, right? So this is what the southwest monsoon wind looks like. Then coming to northeast monsoon. So in winter, what happens? In winter, that sun will go south side. So there will be low pressure in south, and there will be high pressure as there is cooler northern continent, okay. As we have discussed, the land mass will warm up faster and cool down faster. So there will be very cool temperature or cold temperature in China, Mongolia, Russia, and like that. So the wind will move from high pressure, and cool temperature means high pressure belt. So it will move from China, Russia towards the ocean part, okay. So the wind will move like this, okay. As we know, in northern part, okay, so how the winds moves? Like this, okay. So it is also called northeast wind, northeast trade wind. So northeast trade wind, it will move over China, okay. And as the northeast trade wind, when it reaches Himalayan, again eastern Himalayan, they will be deflected. They will be deflected by this eastern Himalayan, and they will move like this, okay. Because Himalayan range is very tall range, okay. So when this northeast trade wind comes from China and Russia, they will be deflected eastward and they will move like this, okay. And after moving through Bay of Bengal, and it is northeast trade wind, so after moving through Bay of Bengal, it will have some moisture and it will precipitate at eastern Andhra Pradesh and the Tamil Nadu, okay, eastern Andhra Pradesh and Tamil Nadu. So this is how Tamil Nadu and eastern Andhra Pradesh gets rainfall from northeast trade wind or northeast monsoon wind, okay. So this is the total phenomena of southwest monsoon and northeast monsoon. Are you clear? Now coming some monsoon deviation, like we have the El Nino and La Nina phenomena. So I'll just discuss about that in brief. If you will ask me how many, what is the normal precipitation, that is somewhere around 1200 mm. In our India, there is total 1200 mm of monsoon it falls, and it deviates year to year. There is deviation, okay. And somewhere the active monsoon period, if you will say the total monsoon period, it is June to September, okay, somewhere 4 months, okay. But in active monsoon period in India, if you will say, that is somewhere July to September, okay, that is the active monsoon period. But if monsoon period someone is asking, then June to September, because it touches the monsoon wind touches the southwest of Kerala during 1st June, and it ends during September, last week of September. Now coming to El Nino and La Nina. El Nino and La Nina. So they are basically global wind circulation pattern. So if we'll say general map of world, then how we see generally the front part of the globe, okay, that is here the USA, North America, South America, just this is Africa, then this is Europe, then Asia, then Australia here. So this is the general map how it looks like. But if you will just rotate it, because from this El Nino and La Nina point of view, if I am rotating the map, then it looks like, suppose this is Australia and this is Northern America, this is Southern America, and this is India, and these are Asia, okay, Asia, Europe. So this is the Eastern Pacific, this is Pacific, and this is our equator, right? This is equator, this is Australia or ocean you can say, and this is the equator, and these are the 30-degree north and south line, right? So what happens generally in general circulation pattern, there is higher temperature at this region, okay, during our summer season when we experience the southwest monsoon. Okay, generally here there is warm temperature, here is cool temperature of the ocean. But when there is warm temperature of eastern Pacific, in some years there is warm temperature or uneven temperature or uneven warm temperature in eastern Pacific. Then what happens, this global wind circulation, there will be this trade wind, north southwest trade wind, that will weaken, and the global wind circulation will weaken, and this wind or this water current that will move, which was moving earlier in normal year like this, that will move towards east, because there is warm temperature in over USA or North America and eastern Pacific. So this wind will move like this, and this will weaken, this southeast trade wind, that will weaken, okay, because that is diverting towards east. So there will be, and this phenomena, the warming of eastern Pacific, that is called El Nino, that is called El Nino. So due to El Nino, what happens, there will be drought like situation in Australia and India, because that southeast trade wind that weakens. So there will be drought like situation, very less rainfall will happen, and there is flood situation, and that type of situation, heavy rainfall, that is you can find in Northern America. So due to El Nino, there is higher rainfall or precipitation in Northern America, but low precipitation over Asia and Australia. Clear? So this is just a warming up of or cool down of this eastern Pacific. Based on that, El Nino and La Nino happens. Okay, that is also called ENSO. ENSO means El Nino Southern Oscillation. El Nino Southern Oscillation, because this is southern part and this oscillation of the sea current happens. So that is called El Nino Southern Oscillation or ENSO, right? So La Nina is just opposite. La Nina is just opposite. This is the warming of the western Pacific and cool down of eastern Pacific. So La Nina, if La Nina is there, then we got heavy precipitation, and this part becomes drought part, like the USA or America, Northern America, that will have very less or scanty rainfall, whereas India and Australia, they will get heavy rainfall due to La Nina. But El Nino is different. El Nino is just opposite. Okay, and which country is affected by this? Those countries which are nearer to the equator, those countries will be affected by this, and which are the part of the Pacific region, okay, or attached with Pacific region, like Eastern Asia, Southeast Asia, then Australia, Oceania, then North and South America. They will be affected very much due to this ENSO phenomena. Okay, El Nino Southern Oscillation. I hope I have cleared all of your concepts. So how this monsoon happens, like we have discussed different southwest monsoon, northeast monsoon, and remember, southwest monsoon contribute around 70 to 75% of total precipitation over India, and northeast monsoon is confined only to some part of India state, that is Tamil Nadu and eastern coast of Telangana. So that is have very less significance in point of for Tamil Nadu and eastern Andhra Pradesh, no doubt. So we get rainfall or precipitation 2 times a year, that is from southwest monsoon and northeast monsoon. And northeast monsoon begins after September. Okay, when southwest monsoon ends, then there is reversal of solar radiation, or the sun moves southward, then there is starting of northeast monsoon. Okay, so we have 2 different peak of monsoon. One is southwest monsoon and northeast monsoon, and we have already also discussed what is the mechanism of this monsoon, what is the windward side or leeward side of monsoon, like why the western part of Western Ghat receives higher rainfall and why the eastern part of Western Ghat receives less rainfall, that is leeward side and windward side. Then we discussed what is El Nino and what is La Nina effect. So if still you have any doubt, you can let me know. And I hope you got all this concept of La Nina, El Nino and the monsoon of India. And if you have still any doubt regarding this or any concept of any like agriculture topic, then you can let me know and I'll prepare a lecture for you. Okay, so see you in the next lecture. Till then, have a great day. Bye bye.